Regine, good morning.
Good morning, ma'am.
Kaya ko nakasulod sa office ay. Asa man ka Regine, kasi mong boarding house?
Yes, ma'am.
Share a window. Under most. Okay, so this meeting is recorded. Okay, so last time we have discussed, ang atong last nga na-discuss class is the fundamental theorem of calculus, and then we started with the fundamental theorem for gradients. Okay, so the fundamental theorem for gradients states that uh you have sorry you have the integral of the integral adjust lang class the integral of the gradient of a scalar function dot dl is equal to t sub t of b minus t of a. Okay, so it is just equal to sa pala aning answer sa minus. So equal to this one, no? So getting B og A, so this is the boundaries from A to B, or the starting point and the end point. Okay? So we have here an example. For example, you have a scalar function t, which is equal to xy squared. So let t be equal to xy squared. And we have to take the point A and take point A to be the origin. That is 0, 0, 0. And the endpoint, are identical. So take point A to be the origin, and the endpoint B, ay pareha na daw sila, identical. Okay, so, ay, sorry guys. So, ito siya challenge, no? And the endpoint B, say for example, it is the point 2, 1, 0. So, it is defined by this point, 2, 1, 0. So, check the fundamental theorem for gradient. Kasulod na si Sheila. Okay.
Wala po, ma'am.
Wag naman si Sheila sa gawas. Wala siya guro internet. Okay. So, for this, say first na to buhaton. So, recall that dl is equal to x dx x hat plus dy y hat plus dz z hat. Okay. And then, t is given, which is equal to xy squared. Now we have to get the gradient of t. So how do we get the gradient of t, gani class? So the gradient of t is equal to, you have partial derivative of t with respect to x, so it is a vector function, plus the partial derivative of t with respect to y hat, plus the partial derivative of t with respect to z hat. Okay, so this is equal to, what is the partial derivative of this scalar function with respect to x? So you have here y squared, no? Y squared x hat plus the partial derivative of the scalar function with respect to y. So you have 2xy. Okay, so you have 2xy y hat. And then you have wala tayo term along the z-axis. Okay, so this is the gradient of the scalar function. Now, let us then get the right-hand side of the equation. So, ato sang unahon og evaluate ang right-hand side of the equation. And then, let us see if it is equal to the left-hand side of the equation. Okay? So, first, we evaluate this using katong integral nga atong na-learn. Line integral. Okay, so for the first path, say for example, ganing 0, 0, 0. Okay, so this is three-dimensional, but since wala man po tayo x, wala tayo z, so we can have this illustrated in a two-dimensional coordinate system. Okay, so this is your y, this is your x. So this is point A, the origin, point A. And then the point B is 2, 1, 0. So naa siya, for example, this is 1, 2. Okay, so this is 1. Kini siya kay pareha kataasan ni 1. Alright. So naa siya diri, no? 2 ang x, tapos 1 ang y, 0 ang c. Okay, so naa siya diri. So this is your path. Okay, so this is point A, this is point B. And then, pwede ta mag-set og path 1, which is gikan diri, gikan sa origin, padulong sa 2, 0, 0. And then, padulong dayon diri sa 2, 1, 0. Okay, so there are two paths. No? So, pwede ka diri, pwede po, pwede ka maagi diri. So for this, masay constant ani. Si x, no? X equals 2. Okay. So for that, x equals, sakto ba? No, si x kaya nagka-increase siya, class. X is increasing. So ang constant diri is si y. Okay? So for path I, kini siya nga path, no, from the origin towards this point, ang constant, so bisag mag-move ka from here to here, ang constant ana kay ang y. So wala ga change ang value sa y. Y is equal to 0. Okay? And then it is along the x, so you have dx x hat. Okay, so that if you take, the gradient, if you take the gradient of t dot dl, you will get, so imo ang gradient of t is this one. And then imong dl class kay dx x hat man. Your DL is just equal to dx x hat. Therefore, ang delta, the gradient of t dot dl is just equal to y squared dx. However, your y is equal to 0, so for path I, you will get 0. Okay? So if you take the integral of this, you will get 0 also. Ito ba? The integral of 0 is 0 also, no? Ito ba, class?
Yes, ma'am.
Integral of gradient of t dot dl is equal to the integral of 0, which is equal to 0. All right, so that is for the first path. Now, for path number 2, this is your path number 2. Okay, so for this, ang constant as you go up, ang constant is ang x. So x equals 2. And then your dl is equal to dy ra, no? Kadira sila. Okay, so you have dy y hat. Okay. Magana akong mouse. So for the second path 2, x equals 2. And then your dl is just equal to dy y hat. Okay, so that the gradient of t dot dl is equal to sa ganito. The gradient of t is equal to y squared x hat plus 2xy. So you have 2xy dy. And then for this, x is equal to 2, so you have 4y dy. Okay, so you have 4y dy. And then integrating this, you have 4y dy. Integrating this from 0 to 1. Ano ba itong 0 to 1? Because ang imong y is from 0 to 1. Okay? So you have 4y squared over 2 integrated from 0 to 1. So we will get 4 times 1/2. Ito ba? So we get 2. Therefore, the integral of the gradient of t dot dl is equal to 2. Now, the total line integral, we just have to add katong sa path 1 o sa path 2. So, 0 man tong una, no? So, the gradient, the integral of delta t, the gradient of t dot dl is just equal to 2. Okay? Now, we take the left-hand side of the equation. So let us try the left-hand side of the equation and see if we will arrive at the same answer. So ano na siya, class? You have t sub b minus t sub a. So this is equal to xy squared Ano xy squared naman siya? Xy squared, this is your t, right? So, evaluate lang nato atong function. So, recall that our function, t is equal to xy squared. So, we just have to evaluate this for x equals 2 and y equals 1. So, di ba, ang b is kini siya nga point 2, 1, 0. Okay, so kini siya, this is your x, this is your y. Okay, minusan din siya nato og xy squared, which is evaluated from x equals 0 and y equals 0. Okay, so your a is 0, 0, 0, the origin. All right, so from here we have x squared, x 2 times 1 squared minus 0. So this is equal to 2. Okay, so pareha sila. So this is easier, no? This is better compared to katong kaganina. So daghan pa kang i-consider kaganina. Kuhaan pa nimo una ang gradient ni T. Tapos dot product pa gud ka. Tapos integrate. So daghan kaayong math ang involved. This one, imo lang i-substitute ang values sa imo ang endpoint o sa imong starting point and then subtract. Okay? So that is the fundamental theorem for gradient. Do you have questions? Okay. So next,
So,
yes?
ma'am. Ma'am, kato bitong sa Pilmero, ma'am, katong na ay gradient of T equals gradient of T over katong kanang equal, ma'am, ba? Hagin nakuha, ma'am. Kanang y
Dapit.
squared. Kanang y squared.
Okay. Gi-evaluate ni nato siya, Lujin. Say for example, kini man atong function, no? Scalar function xy squared. So, differentiating this with respect to x, i-differentiate ni siya nato with respect to x. So, you have y squared lang, no? Y squared. So, derivative of xy squared with respect to x is just equal to y squared. So, you have this one, y squared x hat. And then, the second term is, gikan gihapon siya diri, i-differentiate nato ang t with respect to y. So, you have 2xy. Okay?
Okay, ma'am. Thank you.
Okay, so since wala man tay z component, wala man tay dili dependent si t sa z, so 0 ato ang kining component along the z-axis. Okay? Okay, so we also have the fundamental theorem for divergence. So last time, katong kaganina, no, fundamental theorem for gradient. So naapod tayo fundamental theorem for divergence. Okay. So now it is a volume integral. The fundamental theorem for gradient is a line integral. For the divergence, we have d tau. Okay, so this one is the divergence of a vector function. So v here is a vector function multiplied by d tau. So now we can equate this, or this is equal to the closed integral of v dot dA. Okay, so whenever you see, for example, a volume integral of the divergence, it is actually the same as taking the closed integral of the vector with respect to a surface. Okay, so please take note of this. This will be very useful, class. Okay, this has special names sa MATP. Okay, so I guess murag naabot ra guro mo ani sa inyo ang MATP. So you have the Gauss theorem. Can also be called as the Green's theorem or the divergence theorem. Okay, so ang ubang problem ani kay use the divergence theorem to evaluate ano siya. Okay, so may meaning ani, class? So from this equation, it says that the integral of the divergence over the volume, the integral of the divergence over the volume is just equal to the volume. It is equal to the value of the function at the boundary. Okay, so for example, you have a spherical, you have a sphere. So, I'm pag-drawing ang sphere class, something like this. Okay, so, naka-sphere. And you want to get the integral of the divergence of a vector function over this sphere. So, instead of doing this, kining nasa right-hand side of your equation, pwede ra siya kini imong gamiton. Okay? So, this will be a lot easier. For example, kung sphere, ang imong dA ana kay 4 pi r squared. Okay? So, muna siya ang surface sa imong sphere. So, tanawon lang din mo ang radius. So, from 0 to katong radius. Okay? Now, here's a geometrical interpretation class. If the vector function V represents the flow of an incompressible fluid, then the flux of V is the total amount of fluid passing out through the surface per unit time. Or, in other words, kung naa kay integral sa faucets within the volume, equal ra na siya sa the surface integral of flow out through the flow out okay? So, naakay, ang sapana ni, naakay faucets nga nag pour out og liquid. So, kini siya mo ni siya ang faucets nga nag pour out og liquid. So, equal na siya sa katong, madto ka sa boundary, tapos i-measure nimo ang flow at each point. And i-add lang din siya nimo. Okay? And then, aside from the fundamental theorem for divergence, we also have the fundamental theorem for curls. Okay, so, ang problem ani class kay hatag lang nako as exercise. Okay? So, the fundamental theorem for curls. Or this is known as the Stokes theorem. Familiar man siguro mo ani class? Green's theorem or the divergence theorem, then kini siya, this is the Stokes theorem. Okay, so if you have the surface integral of a curl over some surface, this is just equal to the volume, the line integral of v dot dl. So this one is relating a surface integral to a line integral. So kung nakay ing ani nga form nga surface integral, you can actually convert it, or this is just equal to the surface, the line integral of the vector dot dl. Okay? So it is a line integral. So, sa may geometrical interpretation ani class, geometrical interpretation nga medyo makalibog hapon. So far, ang iyang gihatag nga geometrical interpretation kay murag i-relate niya sa kuan fluid, no? Fluid. Okay. So, the region of high curl is a whirlpool. So, the integral of the curl over the surface or the flux represents the total amount of swirl. Okay? So we can determine this also by going around the edge and finding how much the flow is following the boundary. Tapos i-add up lang din nimo. Okay? So, ano to? Ang region of high curl is mura siya whirlpool. Okay, so imagine na kay whirlpool. And then, the integral of the curl, ang integral sa whirlpool over the surface represents the total amount of swirl. So, ganyan ang swirl, class? So, mula siya moving nga ka ng, di ba, whirlpool, kaya mula siya naigap, na ay, mura po siya og, kung ang kuan, divergence kay faucet, ang curl, kaya mura siya ka ng, katong sa sink, gani nga, pag magbubukag daghang water, kay, mukuan siya dito, mo swirl siya dito nga part sa sink. Okay? We can determine this also by going around the edge. So, magtulang ka sa edge sa imo ang surface. Tapos, you have to find how much the flow is following the boundary and you have to add it up. So, for the boundary line integral, asa daw ta nga, usa atong direction. So, naay ko ano, naay duha ka direction. It can be clockwise or counterclockwise. Okay, so para dili ta maglibog, this will be our convention. So if your fingers point in the direction of the line integral, then your thumb fixes the direction of dA. Okay, so for example, kanino? So naa kay gaswirl. For example, imo ang fingers, class, imong upat ka fingers except sa thumb kay ingani iya ang direction. Okay? So ingani ang direction. So this is the direction of your DL. Now, the direction of your DA is where your thumb is pointing. Okay? So asa man kung ingani ang direction kung counterclockwise nino, counterclockwise ang direction sa imong DL, then ang imong DA is asa man dapit Sheila. Dili no? So this is the direction of your DA. Okay? So if counterclockwise ang boundary line integral, so ang imong DA is pasaka. Kung clockwise pod ang imo ang DL, then paubos pod imong DA. Okay? So we have this corollary. Okay, so the integral of the curl of V dot dA depends only on the boundary line. So it depends only on the boundary line. Not on the particular surface used. Okay? And not on the particular surface used. So dili siya mag-matter di ay kung unsa ang surface. And then the second corollary, the surface integral, the closed integral is equal to 0 for any closed surface. Okay, nga naman ni, ang say reason ani class, if the closed integral of the curl of V dot dA is equal to 0 for any closed surface. This is because ano kaya ni? So this is because the boundary line shrinks to a point. Okay, so ang boundary line, say for example, ang imo ang kini siya no? if this is a closed integral, then this is equal to 0 because your boundary line shrinks to a point like the mouth of the balloon. Okay? So, hagay ng mouth sa balloon katong asa ka mag butang og hangin class. Okay? So, like the mouth of the balloon, it shrinks down to a point. Okay? So, hence, the right-hand side of Stokes' theorem vanishes. Aha, ni ang right-hand side. So, kini, this one. Okay. So, it's already, 8:30 man tatama, no? So, we can proceed to the integration by parts. Kini, ganahan gid mo ani. Okay, so we are done with the fundamental theorem for calculus of calculus. So we have 3. So fundamental theorem for gradient, for divergence, and for curl. So hopefully kay madumduman pa ni siya nato class if ever maka-encounter tag problems later. Okay?
Okay, ma'am.
So we will proceed to integration by parts. This is another technique, no, that exploits the product rule for derivatives. I-discuss pa ni nato or master na mo ani?
So, dapat i-discuss na lang, ma'am.
Discuss, ma'am.
Okay, so recall that integration by parts, kung nakaingani na nga form, no? Duha ka function, f, g. So, if you have two functions, f and g, and then you take the derivative with respect to x, then this is just equal to f dg over dx plus g df over dx. And then, integrating both sides. So, integrating both sides and invoking the fundamental theorem. Okay, so let's integrate both sides. So you have d dx of the function f times g dx is equal to the integral of, suppose we are integrating from point A to point B. So you have f dg dx from A to B. You have plus the second term sa right-hand side of your equation, g df dx dx. Okay. So you have this one. Now, we know the integral of this. So, naka-integral of a derivative, this is just equal to f times g. So, evaluating this from A to B. Okay. And then for the right-hand side, you have, let's just copy this one as is, f dg over dx times dx plus the integral from A to B of g multiplied by the derivative of f with respect to x dx. Okay. Now, i-rearrange lang ni siya na to, class. Let us rearrange this one. Rearranging this one such that, so ang gani? Kini siya to ang nasa left-hand side. So, f, the integral of f dg dx dx from A to B is just equal to, positive ba ni siya, no? So, palhin ni siya na to. Sa pikas nga side, may mo siyang negative. Negative of the integral of this. So, g multiplied by the derivative of f with respect to x dx plus this term. So, you have f times g from A to B. Okay, so this is integration by parts. Okay, so for example, we have here an example class. Evaluate this integral. Let us evaluate this integral. So, di pa to na to masabtanaw. So, let us take an example. We have the integral of x e to the minus x dx from 0 to infinity. Okay, so we will integrate this using integration by parts. So, any idea? Unsa ano siya nato pag-solve? John Paul? Ano si John Paul? John Paul, duha ka John Paul na ang duha ka John Paul. Okay, so anyone sa duha ka John Paul, either John Paul 1 or John Paul 2.
Wala po kayo idea, ma'am.
Okay, so for this, we have to let sa ganito itong form sa itong integration by parts. So na kay F tapos na po kay dg o dx. Okay, so you have to let one be equal to F and then the other one be equal to the derivative of g with respect to x. Okay, so let F be equal to, so pwede ta mag-trial and error ani. Okay, pwede na to, kini siya siguro atong F, pwede kini ato ang derivative of g with respect to x. So, di ba naman tayo ang nga form? The integral of f dg over dx. Okay, so muna siya ato ang tanawon. So, siguro since ani man niya pagsulat, so muguro niya atong x, atong f. So, let f be equal to x and then the derivative of g with respect to x is equal to e to the minus x. Okay? So, if you have dg over dx, then you can get the value of your function g. Pila mang g ani class. So, ang ito siya pagkuha, you just have to integrate both sides. So, in order to get g, you have
Negative.
dg equals e to the minus x dx. Okay, so integrate both sides. Sakto ba? Integrate both sides, no? G, no?
Yes, ma'am.
Okay, so the integral of dg is g and then the integral of e to the minus x dx is, so ang ganyan siya?
Negative
Negative
ito.
e to the minus
Negative.
x, right?
Yes, ma'am.
Diba? Mag e to the u man e to the u du. Okay, so this is your g. You have your f now. You have your g. Okay, so therefore, the integral of x e to the minus x dx is equal to, so ito siya, negative of the integral of g multiplied by df over dx times dx plus f times g evaluated from a to b. This one is from a to b also. Okay, so this particular example, our limits is from 0 to infinity. Okay, so you have minus the integral from 0 to infinity of g. So what is your g? Nakuha naman na to si g, no? Negative e to the minus x. And then your df dx, so we just have to integrate this with respect to x. And unsa to makuha? Integral, derivative of x with respect to x, that is 1, no? Plus?
Yes,
It's
ma'am.
1. Okay, and then copy lang din nato ni si dx plus your f is x multiplied by g, which is negative e to the minus x. Okay, so this is integration by parts. Ang ato lang dahil evaluate kay kini siya. So you have positive integral of e to the negative x dx plus, it's minus. Minus na siya, no? Minus
X.
x e to the minus x. This is
Ma'am,
from 0 to infinity.
negative sa before integral, ma'am ay.
Kani?
Ay, Ay, ma'am, mawala
Yeah,
man eh.
pero kuha na siya, na cancel. Ay, mura siya negative times negative, hindi mo siyang positive.
Mm-mm.
Okay, so let us evaluate this one. Simpler na siya, no? Kay e to the integral of e to the minus x na lang atong evaluate dx. So, unsa answer, anak class? Negative e to the negative x, right?
Yes, ma'am.
Diba?
Makancel
So,
mo ng
the integral, copy lang na to, balik, is equal to the negative e to the minus x evaluated from 0 to infinity plus f times g. So, negative na lagi niya siya. Minus x e to the negative x evaluated from 0 to infinity. Okay, so let us evaluate this from 0 to infinity. So, ang ganit ni siya. So, you have negative of e to the negative infinity minus e to the negative 0 minus x. Ang x di ay class kaya ito na siyang i-multiply pa. Infinity. Tama ba? No? Ang x dire kaya ito pa siyang ilisan og infinity og 0. So, x multiplied by, makabalo ma-evaluate ani, e to the negative infinity minus e to the 0. So, unahon lang sa na to class kung na-away mahabilin. Okay, so from here you have negative of 1 over e to the infinity. Pila man yung e to the infinity class. This is so great that I think vanish ni siya nga term. Sakto ba? Do you have your calculators with you? So 1 over, pwede man ni siya na tumambalin sa denominator kay ang power niya kay negative man. So 1 over e to the, you can also evaluate diretso sa inyong calculator e to the negative infinity and see kung pila answer class. Can you help me with this? So this one is 0. Okay, so this is 0. How about e to the negative 0 or e to the 0? It's 1. Sakto ba? E to the 0 is 1? Or 0 happening class? Ha?
Yes, ma'am.
Okay, so e to the 0 is 1 minus, kaniki, di ko kabalo ma-evaluate ano din nga part. So if, okay. So if x is equal to infinity, then kini siya nga term diri kay, if x is equal to infinity, this term here will become 0 man eh. Kung infinity siya, infinity times, mali ni siya akong gibuhat actually kas, sorry. Ani da siya, oh. Dapat na ay, kuan diri, parenthesis. Tapos, nano po kay x times e to the 0. Okay. So, kini siya nga term kay ma-0 siya bisag unsay value sa imo ang x. So, if x equals infinity, then kini siya nga term diri mahimong 0, right? So, infinity multiplied by 0 is still 0. Minus, kani pa gyud. Kung x nimo kay 0, e to the 0 is 1, so 0 gihapon ni siya nga term. So, the second term will vanish. Okay ra? Okay ra? Nasabtan ba, no? You have equal to 1. Negative times negative 1. So, ang habilin is positive 1. Okay ra, ni diri no? Anong na 0? Ano ganito? Because when this is equal to infinity, if x is equal to infinity, multiply siya nimo ani, this term here is 0 man. So, 0 gihapon. Now, if x is equal to 0, multiply nimo og 1, so 0 gihapon. Okay? Therefore, using integration by parts, we have obtained the integral. Okay. Now, we can also exploit the product rules of vector calculus together with the fundamental theorems in exactly the same way. So, for example, product rule number 3. Yes, this one. So, the divergence of FA is equal to F multiplied by the divergence of A plus A multiplied by the gradient of F. So this is product rule number 3, and we have, I guess, discussed this mga several weeks ago. Magisulat to siya na to, class. Okay? So integrating this over the volume. So let us use integration by parts as well as katong the fundamental theorem for calculus to integrate this one. So integrating this over the volume. Okay, so this means that initially integrate na to over the volume ang left-hand side o ang right-hand side of the equation. So you have the integral of, so i-copy lang nako, multiplied by d tau. Okay, so integrating over the volume. So we have the integral of, katong sa right-hand side, you have f multiplied by the gradient of a, d tau gihapon, plus the integral of a multiplied by the gradient of f, d tau. Okay, now according to the fundamental theorem for divergence, no? So this is divergence. So kung nakay volume integral sa divergence, this is just equal to, sige ito, the surface integral of v. So muna siya itong v. So recall the divergence theorem. According to the divergence theorem, the volume integral of the divergence of v d tau is just equal to the surface integral of v dot dA. So in this case, ang ato ang v class kay kini si f times a. So naa kay f times a dot dA. Okay? So kini siya is just equal to this one. So you have this term here. Ay, kini siya nga term diri. The integral, so murag mo man ni siya ato ang f times dg over dx kaganina. So, muna siya ang nasa left-hand side sa atong equation. So, kung nakadumdum pa mo ito ang integration by parts, so di ba na ito f multiplied by dg over dx sa left-hand side of the equation. So, you have f multiplied by the divergence of a d tau is equal to the negative of this. Okay? So this is equal to the negative of this. Ibalhin ni siya nako diri sa pikas. Negative of the integral of a dot the gradient of f d tau plus the surface integral f times a dot dA. Okay? So you have to take note of this. Mura ni siya og integration by parts using kaning na yung mga divergence. Okay? So, saan man ni siya na to? Na ay exercise diri class. Show that this will be your assignment. So show that the surface integral of f multiplied by the curl of a dot dA is equal to this term, a cross with the gradient of f dot dA plus the line integral fa dot dl. Okay, so for this, you will be using the same concept class. Kini siya kay Stokes theorem inyong gamiton. Okay, so gikan mo sa product rule number 5. Okay, so from product rule, ang hint kay from product rule number 5, hint. So this will be your assignment, ha, hint. Start from product rule number 5. And use Stokes theorem. All right. Okay, so this will be your assignment. Now, we have 10 minutes para ma-discuss, makastart tag-discuss sa curvilinear coordinates. Hello? Okay,
Yes, ma'am.
model.
Yes, ma'am.
Okay, so the first coordinates that we will be encountering is the spherical polar coordinates. All right. So instead of XYZ, we will now have R, theta, and phi. Okay. So this is the spherical polar coordinates. Let us define each of this. So R is the distance from the origin towards the point P. Okay. So for example, class, you have diba ang naandan kay we have a three-dimensional coordinate Cartesian coordinate system. And then for example, this is X, Y, and Z. You have here a point. Bisag asa there is a space. Okay, so point P. So point P in the Cartesian coordinate system can be described or can be located using kung kabalo ta kung unsa yang X, Y, and Z, then we can easily locate the point. Now we can also express this the location of the point using the spherical polar coordinates. So the same P, the same point class, pwede na siya na to ma-express as R, theta, and phi. Okay? So R is the distance from the origin towards the point P. So this is your R. And then theta is the angle down from the positive z-axis. So it can also be called as the polar angle. It is the angle down from the positive z-axis. Okay, so this means that gikan diri padulong sa imo ang r, pwede na nimo ma-measure ng angle. So muna siya ang polar angle class. Gikan sa z-axis, padulong aning imo ang linya from the origin towards the point P. So that is your theta. Imagine na ninyo. And then, yeah, it can also be called as the polar angle. And then your phi is the angle around the positive x-axis. The angle around the positive x-axis. And it is also called the azimuthal angle. Okay, so for the azimuthal angle, kini siya class kay murag naman ni siya anino, kini si R, na ni siya projection along the XY plane. Okay, so akong i-drawing ang projection ni XY, ni R diri sa XY plane. So mura siya anino niya, diri no? Eh, di ba, three-dimensional man ta, so murag, yeah. So naa siya anino diri. And if we measure the angle from the positive x-axis towards the projection of R along the XY plane, this is your phi. Okay? So, nakuha ninyo ang difference sa theta o phi. So, theta is measured from the positive z-axis towards the line joining the origin and the point. Tapos, ang imo ang phi is the angle from the positive x-axis towards the projection of R along the XY plane or in the XY plane. Okay, so that is your spherical polar coordinates. Now, how are they related with the XYZ plane? Okay, so it is important that we know the relationship between the spherical polar coordinates and the Cartesian coordinates. All right. So x is equal to, haman imong x class? Kanino? Diri no? Kung naadiri imong point, imong x kay murag pwede man na siya nimo gud i-drawing like this. Paana. So this is your x. Kini siya nga length. And then your y is this length, and then z is of course this one. Okay, so from here, from this illustration, we can see that x is equal to r sine theta cosine theta. R sine theta cosine phi rather. Okay, so ato ni siyang explain nga nung r sine theta cosine phi ni siya. Okay, so this one is R class. Okay, so this is R. And then, you have theta here, no? Kini siya, no? If you take a point, a line, diri gikan sa z-axis, padulong sa imong point, pareha ni siya length ani class. Pareha ni siya length ani, kining orange nga dot dot dot. Orange broken line is just the same length as the kining point gikan sa z-axis joining your point P. Now from here, using trigonometry, we can see that kini siya nga side is adjacent or opposite to angle theta. Hello, Philippines?
Opposite, ma'am.
Opposite, okay. So,
Yes, ma'am.
since this is opposite to angle theta, then ang length ani niya class is equal to r sine theta. Okay? So if this is r sine theta here, then kini daay nga length po diri kini orange nga broken line, since pareha raman sila, ang length ani is r sine theta. Now your x is kani, no? Kini mong x. Yes, this one. Akong i-highlight. This is your x. And then, it is also, why the any class? This is y. This is your x. Okay? So, this is your x. And as you can see, this is the same as this. Kung unsay length ani padulong diri is the same as this one. Okay? So, this length, kini siya nga length is adjacent to your angle phi. So, since this is your hypotenuse, kung this is a right triangle, muna siya imong hypotenuse. The hypotenuse has a length equal to r sine theta. Tapos, kani siya nga length is equal to the hypotenuse multiplied by cosine theta. Kaya nga na ganito, ay cosine phi di class. Cosine phi kay adjacent man siya kay angle phi, right? So that is why you have r sine theta cosine phi. Okay, nakuha ninyo? Bernadette? Do you have questions? Si Bernadette. Cherry?
Ma'am.
Natulog pa ka, Cherry?
Ma'am, oy.
I'm just checking if nakuha na ba to ninyong explanation? Or kung wala kay any comment, class? Hello?
Okay, ma'am.
Okay. So it's already 8:30 class. So we will continue this discussion sa next meeting. Okay?
Okay, ma'am. Okay, ma'am.
Pero sa inyong online gihapon ta?
Yes, ma'am.
Okay.
Okay ra, ma'am.
So, goodbye class.
Bye, ma'am. Thank
Bye,
you, ma'am.
ma'am.
Thank you.
Natagan ako sa AS12 ka.
God bless.
Ay, ma'am, i-con rin mo, ma'am. I-post rin mong video, ano eh. Thank you, ma'am.